Alright, so in this video we're going to check out 2021 AP Calc AB FRQ number 6. This was the last one from the test. And it was a differential equations question. So, question says we have a medication that is administered to a patient, and the amount in milligrams of the medication at time t hours is modeled by a function y equals a of t that satisfies the differential equation. And then it gives us that differential equation. It says at what time t equals, it says at time t equals 0, there are 0 milligrams of the medication in the patient. So I'm just going to make a little note here, maybe for later, that a of 0 is actually equal to 0. Okay. So letter A here says a portion of the slope field for the differential equation is given below. It wants us to sketch the solution curve through the point 0, 0. These are always pretty much gimme questions as we go here. So we're going to have some sort of curve that follows this asymptote right here. Okay, fairly simple for that first one. And we can see that there's that horizontal asymptote at the line. And actually directly related to that, I believe, is letter B. So it says using correct units, interpret the statement, the limit as t approaches infinity of a of t is equal to 12 in the context of this problem. So this is basically saying that as t approaches infinity in this function, we start to approach a value of 12. Now, what does that value of 12 mean? Well, a of t is in milligrams. Okay, so what this means is as t approaches infinity, okay, and maybe we can put this just a little bit more specific. It says the amount in milligrams of the medication in the patient at time t hours. So we can say as t approaches infinity, the amount of medication in the patient approaches 12 milligrams. It's a little weird because that means that the medication never actually leaves the patient, but AP just likes to ask lots of odd questions like this, and so in the context of this problem, well, we're just saying that that amount of medication will remain in the patient as t approaches infinity, and that amount is 12 milligrams. Okay. All right, letter C. You can always expect to get one that's like this on a differential equation question. It says use separation of variables to find y equals a of t, the particular solution to the differential equation dy dt, and they give that to us here with the initial condition a of 0 equals 0. Okay. All right, fairly straightforward question right here. So we're starting out with this differential equation. Okay, usually get 1 point on these problems just for straight up separating the variables. So I'm going to begin here by multiplying by the reciprocal of 12 minus y to get the y's on the left side, and I'll multiply dt over to the right side. Okay, and then from here, what I'm going to do is I'm going to start taking the integral of both sides. Okay, start out with the easier side here, which would be the left side. We will go ahead and write this as 1/3 t plus c. On the right side, you could use u substitution here, or if you're just thinking ahead, anytime I have 1 over something to the first power, it's going to be the natural log of the absolute value of that something. So in this case, 12 minus y. But in order to account for the fact that we have a negative y on the inside, we need to put a negative on the outside. You can double check that. By just taking the derivative of that, we would see that when we're done, we get 1 over 12 minus y. I like to go ahead and solve for c right off the bat. Other people like to wait till later. It's really up to you. But I'm going to go ahead and plug in 0, 0 here and solve for c. I'll switch colors while I'm doing this. So it's going to be negative natural log of 12 minus 0. The absolute value of 12 minus 0 is equal to 1/3 times 0 plus c. Okay, 0 times anything is 0. So when I finish here, I get the negative natural log of absolute value of 12 minus 0 is just 12. Okay, so here is my c value. Okay. Typically, as they score these, you get a point for separating the variables, you get a point for getting the correct antiderivatives, you get a point for solving for c, and then last but not least, we have to solve this for y. So I'm now going to take this, put this back over here, negative natural log of 12 minus y, absolute value, equals 1/3 of t minus the natural log of 12, because I'm going to substitute that in for c. Okay, now I'm going to solve for y. I'll start here by getting rid of the negative on both sides. Okay, so I'll make both of these terms negative on the right side. Okay, change their signs. I can actually drop the absolute value bars if I want, because my initial condition has a y value such that when I plug that in, I don't end up taking the natural log of a negative number. 12 minus 0 is 12, and that's just fine. So I'm actually just going to turn these into parentheses here. I'm going to convert this from exponential into, or sorry, from logarithmic into exponential form. So I'm going to essentially write this as e to the power of all of this stuff on the right side of the equation. Okay, and then from here, I'm going to add y to the right side and subtract this from the left side. So when I'm done, I'm going to have 12 minus e to the negative 1/3 t plus the natural log of 12, okay, is equal to y. And you could change this up just a little bit more by using properties of exponents and logarithms. This right here is e to the power of essentially a plus b, which is equal to which is equal to e to the a times e to the b, except in our case, that b is natural log of 12, and when I raise e to a natural log, that goes away, and I'm just left with 12. This whole thing right here becomes 12, so now 12 times e to the a. So I'm going to go ahead and write this as 12 minus 12 times e to the negative 1/3 t. Okay, and here is my final answer for this problem. And so this is usually worth about 4 or 5 points on one of these, and that last point comes from solving for y. And last but not least, we come over here to letter D. It says a difference. Procedures used to administer the medication to a second patient. The amount of milligrams of the medication in the second patient at time t hours is modeled by, and it gives us a differential equation that satisfies that function. And it says at time t equals 1 hour, there are 2.5 milligrams of medication in the second patient. Okay, so I'm going to make a note here. That means that B of 1 is equal to 2.5 milligrams. And it wants to know, is the rate of change of the amount of medication in the second patient increasing or decreasing at time t equals 1? Give a reason for your answer. This is a slightly confusing question in terms of how it's written right here. But what it wants to know is dy dt increasing or decreasing? Okay, well, the only way that we would find if a rate of change is increasing or decreasing is we would have to take its derivative. It's kind of like thinking about the relationship between velocity and acceleration. If you want to find out if velocity is increasing or decreasing, well, you have to look at the acceleration. So in our case right here, what I would like us to do is start by figuring out if this is my derivative right here, okay, and for the sake of notation, I'm going to call this y prime. I would like us to start by finding y double prime. Okay, so if we find y double prime right here, the derivative of 3 is 0, and I have a quotient rule problem right here. So I'm going to take that negative out to the front. So quotient rule says low d high. Okay, so derivative of y is y prime. Sorry, let me give myself some more space here. Okay, so we've got low t plus 2 d high, derivative of the top is y prime, minus high y times the derivative of the low, derivative of t plus 2 with respect to t is 1, all over low squared, so that's going to be t plus 2 squared. Okay, and so in order to figure out whether this rate of change is increasing or decreasing, or y prime, we're going to need to figure out whether y double prime is positive or negative. Okay, if y double prime is positive, then that rate is increasing. If y double prime is negative, then that rate is decreasing. So let's go ahead and start plugging some things in here. Again, we have this initial condition that b of 1 is 2.5. So everywhere that I see a t, I can plug in 1, and everywhere that I see a y, I can plug in a 2.5. Okay, so I'm going to go ahead and plug in 1 for t right here. This is 1 plus 2. I'm going to worry about y prime in just a moment. Okay, y right here is 2.5. We're getting our colors right here. So put 2.5 times 1. Okay, really the bottom of this I know is going to be positive no matter what, because I'm taking something and I'm squaring it. And I'm going to plug in 1 for t right here. I do need to figure out what y prime is, okay? And I'm going to evaluate that when y prime is 1. So off to the side here, I'm going to go ahead and say, well, y prime, or in other words, dy dt at the point 1 comma 2.5 is going to be equal to 3 minus y value is 2.5. I'm sorry, the y value, y value is 2.5. T value is 1, so 1 plus 2 should be 3. Okay, we could do some extra work with this if we want. Maybe I'll make this, multiply this by 3, so 9 minus 2.5 is 6.5 over 3. Okay, so wherever I see this y prime right here, I'm going to plug in 6.5 divided by 3. Okay, and again, I'm just trying to figure out if when I'm done, do I get something that's positive or negative? Well, 1 plus 2 is 3 divided by 3. Those are going to go away. 6.5 minus 2.5 is 4. So when I'm finished here, I'm going to get negative 4 over 9. Okay, so if we're thinking about what's occurring right here, that second derivative is negative. So we could say d squared y dt squared, the second derivative, is equal to, or we could say that it is less than 0. Therefore, dy dt is decreasing at time t equals 1. Okay, and that should be a sufficient explanation as to why it's decreasing by taking a look at the second derivative. If the second derivative is less than 0, then that means that the first derivative has to be decreasing at that point. That concludes question number 6 from the AP Calc FRQ for 2021. Hopefully that makes sense.